All right, this is 6.6, solve absolute value inequalities. And earlier, in 6.5, we talked about solving absolute value equations. And absolute value means the distance a number is from zero. So when we talked about the other day, when the absolute value, like we'll say, we'll use for absolute value of x, say equal 3, we made the conclusion that x could equal 3 and -3. So that's what we learned from 6.5. So what will help you the best to describe what we're trying to do to solve absolute value inequalities, if you have your book, go to page 398. If you need to pause, please do so. And if you were to look on page 398, there is a description where it says, recall that the absolute value of x equals 3 means that the distance between x and 0 is 3. The inequality of the absolute value of x is less than 3 means that the distance between x and 0 is less than 3. And the absolute value of x that's greater than 3 means that the distance between x and 0 is greater than 3. The graphs of the absolute value of x is less than 3 and the absolute value of x is greater than 3 can be shown as, so if I had my top one right here where the absolute value of x is less than 3, I can write the graph looking like this. I have -3 and 3. We remember from inequalities because it's a less than, not a less than or equal to, so it is an open circle. And the graph is shaded inside, which we remember from previous sections looks like an and statement. It's graphed like an and statement. And if the absolute value of x is greater than 3, we're still going to have our -3 and our 3. Still is going to be open circle. But the graph is going to show looking like an or statement. Okay? And what is written here in red will give you a better idea of what you have to do in order to solve for absolute value inequalities. So first you have to determine whether, well, first off, when you're solving for absolute value inequalities, the first step is to get the absolute value by itself, meaning that just having the absolute value on one side of the inequality is essential in order to solve it. And so once you get that, you can either use 1 or 2 to help you solve the inequality and also graph the inequality. So for number 1, it says if the inequality absolute value ax plus b is less than c, where c is greater than 0 or equivalent to a compound inequality. I don't think that's how you spell equivalent. apologize. And the inequality negative c is less than ax plus b, which is less than c, which this looks like an and statement, which we learned when we talked about compound inequalities in 6.4. And so number 2 is the absolute value, or the inequality of the absolute value ax plus b is greater than c, where c is greater than 0, is equivalent to the compound inequality ax plus b is less than negative c, or ax plus b is greater than c. So some of that may sound complex, but like for number 2, this would be considered an or statement from what we learned in 6.4. So let's take a look at some examples to kind of help us out. So we have the absolute value of x minus 5 is greater than or equal to 7. So if we look at, is it number 1 or is it number 2? Well, I see I have a greater than or equal to, so I can determine that it looks similar to number 2. So for A, it's going to look like an or statement. So that means that I have to use this general equation to help me out. So I have to now, since I have my absolute value by itself on one side of the inequality, I can now substitute into this general equation. So instead of having ax plus b is less than negative c, I can rewrite it as x minus 5 is less than or equal to, because that's how it is in our inequality here, negative 7. Or x minus 5 is greater than or equal to 7. Now that I have that, now I can solve for x just like we did for solving for inequalities. So I'm going to add 5 to both sides, which gives me x is less than or equal to a negative 2. I'm going to add 5 to both sides, which gives me x is greater than or equal to 12. And so I have negative 2 here, I have 12 here. They're both going to be closed circles because they have the equal to attached to them. And just one second. Sorry about that. Just let me. Okay. Back to the inequality. So we've determined that x is less than or equal to negative 2 and x is greater than or equal to 12. So that means we can now do our shading, because we decided that it was an or statement, and we're going to shade the outside of our graph. Let's look at another one. Well, let me give me some room to work with. Okay, so I have 3 times the absolute value of 5m minus 6 minus 8 is less than or equal to 13. Okay, so before we determine whether it's an and or an or statement, let's get the absolute value by itself on one side of the inequality. So in order to do that, we're going to add 8 to both sides, which then gives, this cancels out. So now I have 3 times the absolute value of 5m minus 6 is less than or equal to 21. Now, since it's multiplication, I'm going to divide 3 to both sides, so that cancels, and that leaves me with 5m minus 6. The absolute value of 5m minus 6 is less than or equal to 7. Okay, so now that I determined that I've gotten the absolute value by itself, I have the inequality. It is a less than or equal to C, which is 7. I can determine that looks very similar to what our number 1 is. So B will be an AND statement, which means now I can rewrite this equation like this, where negative C is less than AX plus B, which is less than C. So let's move down. So now that I have this, I can say my negative C here would be negative 7 is less than 5m minus 6. Oh, I'm sorry, this is less than or equal to, I'm sorry. And this is less than or equal to 7. Because that's how the general equation shows us in the steps for solving absolute value inequalities. I want just a little more room to work with. Yeah, that's much better. So just like now this equation here looks very similar to what we had when we were dealing with compound inequalities. So since it's an AND statement, I can break these up into two different inequalities. I have negative 7 is less than or equal to 5m minus 6, and I have 5m minus 6 is less than or equal to 7. So now that I have that, I got my AND statement. Now I can solve for m. So I'm going to add 6 to both sides here, which gives me a negative 1 is less than or equal to 5m. And I'm going to divide 5 to both sides, which then is negative 1/5 is less than or equal to m. Here I'm going to add 6 to both sides. That cancels. So now I have 5m is greater than or equal to 13. Divide 5 to both sides. That cancels. So now I have 5. So now I have m is less than or equal to 13 over 5. So I can rewrite this inequality either as an AND statement, or I can write it like negative 1/5 is less than or equal to m, which is less than or equal to 13 over 5. And if I were to graph that, so I have negative 1/5 and 13 over 5. Both of them are closed circles because it's equal to and shaded in the middle. All right, last thing we have is deals with absolute value deviation. We talked about that a little bit in 6.5, where if you have the absolute deviation in a given value, you can determine what solve for x could be. So for these examples, we want to write a verbal sentence as an inequality and then solve it. So for A, I have the absolute deviation of x from 6 is less than or equal to 4. So here absolute value is equals x minus a given value. So we can say we know that this is x, and we know that 6 is our given value. So we can write this inequality as the absolute value of 6, or x minus 6, is less than or equal to 4. So I got less than or equal to 4. Okay. And if we recall back from what we learned in these steps here, let's take a look. That is a less than or equal to, so less than or equal to gives us the and statement. So we can rewrite this as -4 less than or equal to x minus 6, which is less than or equal to 4. Now we can rewrite this as -4 less than or equal to x minus 6 and x minus 6 is less than or equal to 4. So I go plus 6 both sides, which gives me, oh, I'm sorry, that's a positive 2. It's less than or equal to 6. And add 6 to both sides, leaves me at x is less than or equal to 10. So if I were to, so this is the how you write it out as an inequality. And to solve it, it would be 2 less than or equal to x is less than or equal to 10. And if you were to graph that, your graph shading would be in between 2 and 10. Let's try one more. So I have the absolute deviation of 2x from -7 is greater than or equal to 15. So using our equation for absolute deviation, I can say that I can say the absolute value of 2x minus a -7, which would make it plus, is greater than or equal to 15. So that's how you would write it from the verbal sentence. And if I were to go back to here, it looks a lot like a or statement. So that means that I can rewrite this as 2x plus 7 is less than or equal to -15. Let's see if that's correct. Yes. And or 2x plus 7 is greater than or equal to 15. So if I were to subtract 7 to both sides here, it gives me 2x is less than or equal to, what would that be? 22. And dividing both sides by 2, which means that would be x is less than or equal to -11. On this inequality, I'm going to subtract 7 to both sides, which gives me 2x greater than or equal to 8. And dividing both sides by 2, x is greater than or equal to 4. So writing this out, I could have x is less than or equal to -11, or x is greater than or equal to 4. And that is how you solve absolute value inequalities. I hope this helps. Until next time.